I'm going to explain about characteristic function with example. So it is denoted with phi x of t, phi x of t. For example, characteristic function means actually it is an averaging process for random variables. It is an average for random variables, but it is an highest average and uh, in special case. So means here the average includes both real and imaginary parts. If x is a random variable and the data is varying both real and imaginary, so then it is, if the data is varied like this, here I am assuming, so it is 10%, it is 20%, and it is 30%, and that is imaginary part also if the data is varied. So then what is an average? This is then one company data, or else 10 bolts are designing here and 20 bolts they are designing next day, 30 days, 30 bolts they are designing next day, 40 bolts they are designing. So means here exponentially the data is varying. Then what is an average bolts they are designing? That is the characteristic function and denoted with the phi x of t, phi x of t. So that's why it is an highest average and also special case average for random variables. So it is denoted with minus infinite to plus infinite exponent e power jtx, e power jtx into f of x dx, f of x dx for continuous random variable, for continuous random variable. So it is just assume it is an e power jt, both real and imaginary parts data they here it includes for continuous random variable. This is an average for continuous random variable, and if it is discrete, we know that for discrete random variable, that is sigma I is equal 1 to n e power jtx into p of x, into p of x. This is phi x of t for discrete random variable, for discrete random variable, for discrete, for discrete random variables. So finally, the characteristic function means nothing else. It is an averaging process for random variables. Universally, they are following this rule. If the data is varied like this, then only this formula will exist. We can calculate the average. So I will give the one example here. We can say this. So example, for example, if x is a continuous random variable and having it is a continuous random variable having density function, having density function f of x equal 1, f of x equal to 1 from 0 less than x less than or equal to 1. Then find characteristic function phi x of t, phi x of t. So for this you will go with solution. So therefore solution, we know that the characteristic function phi x of t for continuous random variable minus infinite to plus infinite e power jtx multiplied with f of x dx, f of x dx. Substitute the limits already is given, that is 0 to 1 e power jtx into f of x means 1 is given dx. So therefore e power jtx integration is e power jtx by jt with respect to x from 0 to 1. E power jt into substitute 1 e power jt at place of x 1 e power jt by jt minus e power 0 means 1 by jt, 1 by jt, because e power lower limit e power 0 equal to 1. E power 0 equal to 1. So this is then phi x of t, an averaging process for the given limits. I will one more model. You may ask the questions from universities. That is second method, example 2. I will give the example 2. If the random variable x is having density characteristic function phi x of t is equal e power plus t from minus infinite to x less than or equal 0, then find density function f of x. Find density function f of x. So therefore we'll go with solution. Therefore here we know that the characteristic function phi x of t is equal e power minus infinite to plus infinite e power jtx into f of x dx. So from this he has given that is f of x is equal throughout 360 minus infinite to plus infinite phi x of t multiplied with e power jtx is e power minus jtx into with respect to t. So this is an density function. This is an density function for x. Density for x, density function. So therefore substitute from this here the limits 1 by 2 phi. The limits are from minus infinite to 0. Phi x of t is how much? E power t. E power t and e power minus jtx dt. So therefore I will take the common 1 by 2 phi e power minus infinite to 0 e power 1 minus jx into t. T I am taking common. So then is equal 1 by 2 phi e power 1 minus jx t is e power 1 minus jx t by 1 minus jx of minus infinite to 0. So this is equal 1 by 2 phi e power 0 is 1. 1 by 1 minus jx minus e power minus infinite is 0. 0 by something 0. So this model is also asking you will give the phi x of t and then you may ask the that is density function, or else one more you will give the density function f of x and we need to calculate that is phi x of t. Thank you.